Hello guys, welcome to the Spring Boot 0 to Infinity course. In this course, we will master the backend development with the Spring Boot, and this is going to be the fifth video of this series. So before proceeding further, let's see what we will learn in this course and currently where are we in this course. So as you all guys knows, this course is divided into two parts. In part 1, we will learn about the Spring Boot backend foundation from the core Java to how we can secure our REST API. So in the part 1, we will learn about the Spring Core, Spring Boot and the MVC architecture and how to create the RESTful APIs. Then we will learn about how we can connect the databases with the Spring Boot in the level 3. In the level 4, we will learn about how we can add the security to our Spring Boot application and make it more secure. In the level 5, we will learn about how we can deploy our application. So in the part 1, we have mastered our backend foundation. So after the part 1, you can build any Spring Boot application. But if you want to scale it, then you have to complete the part 2. In part 2, we will learn about how we can scale our Spring Boot application using the different approaches. So in level 6, we will learn about in part 2, in level 6, we will learn about microservice architecture, how we can do the event-driven programming using Kafka, then how we can do caching with the help of Redis to improve the performance. Then in level 9, we will learn about the Docker and the containerization. And in the level 10, we will learn about how we can test our Spring Boot application. And finally, in the level 11, we will learn about Kubernetes. So this is going to be the whole roadmap for this Spring Boot 0 to Infinity course. So currently we are in the level 1 Spring Core. So this is going to be the fifth video in this level core Spring Core. So what we have already learned in the level 1, in the lecture 1, we have already learned about what is framework, why there is a need of framework, what is the Spring framework, and how is it different from other frameworks. Then in the level 2, we have learned about one of the very foundational thing of the Spring and the Spring Boot, that is the Spring context and the beans, and what are the different methods of creating the beans in the lecture 2. In lecture 3, we have learned about what is dependency, how dependency are injected into the how Spring inject the dependency, and what are the different methods of the dependency injection, auto wiring versus wiring. And in lecture 4, we have learned about how abstraction can be used to achieve the loose coupling, and in the abstraction, how we can do the dependency injection. So in today's video, we are going to learn about bean scopes and the life cycle. And in the next video, we will learn about proxies, aspect-oriented programming, and transaction. So this will cover the level 1 Spring Core. So after completing all this theory knowledge, we will do one mini project based on the notification system, and it is going to be purely from the Spring Core concept, and it is going to be the console based application, because currently we haven't learned about Spring Boot MVC architecture. Once we have read it, then we can build the RESTful APIs, and then we will also do one major project of the Zomato clone using the Spring Core only, and this is going to be the version 1, and this project will evolve with each level. For example, if we learn about the Spring Boot MVC architecture, then we will convert this application into the API, and then when we learn about the databases, Spring Data, then we will add the database to our application. So like that, this major project grow with each level, and there will be a mini project at each level, so that it will make your foundation very strong. So without any further ado, let's start with the today's video. So in today's video, we will learn about the bean lifecycle, bean scopes, and the bean lifecycle. So what we will learn? So first we will learn about how Spring control the bean creation and what is meant by the scope. Then we will learn about how many different types of bean scopes in the Spring, and what is the difference between the singleton bean and the prototype behavior, and what is their use cases. Then we will learn about the Spring bean lifecycle, and then finally we will learn about how the initialization and cleanup happen using the lifecycle callbacks in the Spring framework. So after this video, you will clearly understand what is bean scopes and the life cycle of the bean. So let's start today's video. So first of all, let's see about what is this bean scopes. So as you all guys know, Spring framework is based on the IOC principle, that is inversion of control, in which the Spring creates the object and manages its life cycle. So Spring uses the different approach for the creation of the bean and managing its life cycle. So these different approaches, for example, Spring for one approach A1, A2. So these different types of approaches followed by the Spring is known as the bean scope. So what is the bean scope? So Spring has a multiple different approaches for creating the bean and managing their life cycle. In the Spring world, we name these approaches to the scopes. So what is the bean scope? Spring is based on the IOC principle, in which we don't create the object for ourselves. Spring creates the object and manages its life cycle. So there are different ways in which the Spring creates the bean and manages its life cycle. So these different types of approaches used by the Spring for the creation of the bean and managing its life cycle is known as the scopes, bean scopes. So let's see how many types of the bean scopes in the Spring framework. Let's see how many types of bean scopes in the Spring. So let's say how many types of bean scopes in the Spring. So in Spring, basically there are 6 types of bean scopes, but in these two are the part of the core Spring scopes, and these 4 are of the web applications. So in today's video, we will learn about the singleton and prototyping, and in the upcoming video in the Spring Boot MVC architecture, we will learn about these 4 request session application WebSocket scopes. So what is the focus of this lecture? So in this lecture, we will focus on the singleton and the prototype bean. So let's start with the singleton bean, and then we will learn about the prototype bean. So what is mean by this? What is the singleton scope of the bean? What is mean by the singleton scope of the bean? So as the name signifies, singleton means the single instance. So what is the singleton scope? Singleton means the single instance. So what is singleton scope of the bean? So it means that the Spring creates only one instance of the object and store it in the Spring context. So what is meant by singleton bean? A singleton means that the Spring creates only one object and store it in the Spring context, and this same one object is shared everywhere. Wherever we used this bean, this will be used everywhere, and it is by default it is created at the context starter. So what is the singleton bean? Singleton means that in a single instance, only one instance of the bean is created, and this bean is shared everywhere, and by default it is created at the context startup. And in the Spring framework, this scope is default. So whenever we create any bean, and if we don't specify any scope, it is by default the singleton scope. So let's see it with the help of example. What we will do? So we will create one counter bean and add it to the Spring context and try to get it from the Spring and see how many instances are created by the Spring. So let's see it with the help of example. So open your IntelliJ IDEA, create the new project. I will going to select it to the different part like a video, and let's name it lecture 5 bean scopes and life cycle, and let's select the archetype from here to quick start, and let's create the project. So once it's created, it's going to create a file for us and downloading the required dependency from the Maven Central. So let's come here in the pom.xml, and for using the Spring, as you all guys know, we need to add the Spring core Spring context dependency in our pom.xml. So let's add it. So what we need to do, we need to add the group ID to org.spring framework, and here we need to give the Spring context, and once done this, reload it. Now come to your main file here, and let's cut it. Let's cut it. So how So let's first create the context. So let's create the context. Context is equal to new annotation. Oh, annotation config. So it's not currently not giving the suggestion. So first reload the, so that the required dependency can be added to our application. And to get the suggestion, first close it and then reopen it. So annotation config application context, and in this we will add our configuration file. So first let's create our configuration file. Project config, and let's name it @configuration, and here we will create one bean and add it to the Spring context, and we will add it using the is equal to, sorry, here it's equal to new annotation config, and here name it to project config dot class, and let's convert this to the level 10. And now let's create one class whose bean we want to add to the Spring context. Let's create it, name it counter. And what we will do it, so this in this let's say there is one variable count is equal to 0 initially, and there let's add constructor so that we can understand how many instances can be created. Counter is created. Let's say, and let's say here there are two methods for one to increase the count. So let's add public void add to count, and let's increase the count to 1, and let's add another public int get count, and let's return count. So now we have created one instance, one class, counter class, and let's add it to the Spring context using the bean method call. So as you all guys know, in order to add using the bean method call, we first need to name it to the bean annotation, and then here we need to type it and name the bean name. This is going to the bean name, and let's return new counter. So this, so now our configuration is ready. So now what we have done, we have created one counter class now and add it to the Spring context using the bean method call. So now let's try to retrieve it, and by default we don't specify any scope to this bean. So by default it is going to be of type singleton bean. So let's come here and let's see if we retrieve the two instances, how many instances, and let's say we are retrieving it, and let's see context dot get bin counter dot class, and counter c2 is equals to context dot get bin counter dot class. So basically we are retrieving the bean from the Spring context, and let's see whether it both are same or not by printing is hash code. Hash code is basically like a pointer. c1 dot hash code, c2 dot hash code, and let's also check it with the help of boolean is equal to c1 is equal to c2, and let's print it is equal, and let's run it. So as you guys can see, when the Spring starts, it added the counter instance to the Spring context and created only one instance of this counter class, because by default it is of type singleton, so only one instance is created and added to the context. From here you can see that this constructor is called only one times, so the only one instance of the counter is created and added to the Spring context. and whenever we retrieve it from the Spring context, we are getting the reference to the same bin. As you can see from here, the hash code value of both C1 and C2 are same. So its point is indicating that we are getting the reference to the same bin. And from here we can also see that is equal to true. So by default, scope of the bin is singleton by default. But let's say if we come here, we will learn the scope in grade, prototype scope in grade, but let's come here and add the scope to prototype. If we add the scope to prototype, then the two instance will be created. Whenever time we call the C1, it will give the two instance. From here we can see, if now we from here you can see that the two instance of the counter is created because we are retrieving it two times. We will, no worries, we will study the prototype bean scope in also in the great detail, but I explain you here because you can see clearly that here it is gifting the false. So it is a type of the prototype bean and it is a singleton bean. So let's come here and remove it from here. So by default, the scope is going to be the singlet and only one instance is created. So let's see it with the help of example. So what we have done, so when we do this, so first using this line, we created the context. So upon creation of the context, Spring go to this project config.class, see here and add the counter, create one instance of the counter object, add the bin to the Spring context. And since by default there is not any scope specified here, so by default it is of the singleton type. So basically only one instance of the counter is created and added to the Spring context. So as you all can see, only one instance of the counter is created and added to the Spring context. And whenever we retrieve, we're trying to get it from the Spring context, Spring gives us the bin, reference of the bin of the same bin. So by default, whenever we try to get the reference of the counter type, it is giving the reference to the same bin, because we have already seen that the value of both the hash code are same and this is equal to true because the Spring is giving the reference, because the Spring is giving the reference of the same bin because in the type singleton only one instance is created and added to the Spring context by default. And by default, if we don't specify any scope, it is going to be of the type singleton scope. So now you learn about how we can add the Spring bin to the, how we can add the singleton bin to the Spring context using the bin annotations. Now let's see how we can add the singleton bin to the Spring context, and also how dependency injection of the singleton bin happen in the Spring context. So let's see it with the help of one example. So consider we have two services named service 1 and service B, and both the service depend on the counter class. So basically both the service depend on the counter class, that is counter is the dependency of the service A and the service B, and let's say it is of the type singleton. So the Spring will inject the same bin in both the type, both the service by default, since counter is of the type singleton, and whenever we inject this dependency into any of the services, we are injecting basically the same instance of the counter into all the services. So basically what happens that there is only one counter object in the Spring context, and whenever we inject it, the same bin is injected into each services. So let's create it. So basically what we are trying to create is, let's create the two services. First let's create one named service A, and let's this will depend on its dependency is the counter, and let's inject this dependency using the constructor injection counter this dot counter is equals to counter. Sorry, it's service A, and let's say there is one method in which we update it, public void update. What it will do, it will increase the counter value. So let's print it as auto service A is incrementing the count to incremented the count to, let's say, counter dot add to count. Oh, so come here and count in counter dot add to count, and here counter dot get count, and remove it from here and add it plus. And let's say here we add another method known as public void check that will print the current status of the count. Service A is checking the count value, counter dot get count. So now, and since we are adding it with the help of stereotype annotation, come here and add the type @ service annotations, and let's create another service named service2, and we will copy paste this code and do several changes in it. So come here and name service B, come here and paste it and change the name to the service B, come here service B, and here service B, and here service B. So what we are doing, and also let's name it service class. So now we have created the two services named service1, service A, and service B. These two are the different services, but both are dependent on the counter variable. So what will happen, and let's come here and let's also remove this and we will add it using the as stereotype annotation. So come here and type component, come to the project config, and here write component scan and base packages is equal to org.example. As you can see from here, it is org.example. So what will happen, so Spring will first come here, add it to this add, and let's remove it. And what we will do now, we will get the service A is equals service A as A is equal to context dot get bean of service A. So, and let's say service B as B is equals to context dot get bean of service B, and dot class service B dot class. And let's see, and let's add one method to it for getting the counter. So public counter, so that we can say which are injected, get counter return counter. And let's add this method to the service B also, so that we can verify that both the instances are the same. And let's come here and let's print SOUT SA. So no, first let's check whether both the instances are same or not. So what we will do, so first we will come here and see, we will add one is equal boolean is equals to SA dot get counter is equal to SB dot get counter, and we will print it is equal. And let's see whether both the instance injected. So what we are doing, we have created the two services named service A and service B. Both the services depend on the counter bean, and since we haven't specified any scope, so count by default the counter is of the type singleton in singleton bean scope. So only one instance of the counter is created and added to the Spring context. And now the same counter is injected in the service A because it is of type singleton, and in the service B. In both the services, the same counter instance is injected, and we are retrieving it and checking whether both the counter are same or not. So let's run it. So from here we can see that only one instance of the counter is created, and both in the service A and service B, both the same instance are the same bean is injected in the both the services. So that's why we are getting the true. We can also verify it with the help of, like, for example, in the service A, if we increment the count, so service A dot update, and so it will increase the counter of the service A, because in this there is one update method. What it will do, it will increase the counter of the service A. And in the service B there is one method called check. So let's check it in the service B dot check. So if in both the services, if different counter is injected, then the value of the updation of the service A should not affect the service B. So let's run it. So from here we can see that the service A incremented the count to 1, and when we are checking with the help of service B, it's saying the value 1 because both are pointing to the same instance. So when the counter instance is created, its value is equal to 0, and when we are incrementing the count update, the counter is updated to 1. Since only one instance of the counter is existed in the Spring context, both SA and SB are having the same counter objects. That's why when we are checking with the help of service B, we are getting 1 instead of 0. So let's see it with the help of one example, with the diagram. So basically what happened here is, basically first we have marked the counter as component. So what it will do, it will add the counter object, counter bean to the Spring context, add it, and in both, since service A and service B is of the, we don't specify any scope to it, so it is of type singleton, it is added to the Spring context. And now this service A and service B depend on the counter object. So in the Spring context, since counter is of type singleton, only one instance of the counter is created and added to the Spring context at the time of the Spring context startup. And in both the service A and service B depend on the counter object, counter bean. So Spring inject this counter in both in here and here, the reference to the same bean injected into both service A and service B. That's why when we check it like service A dot get count, we are getting that equal value is equal to true, and when we increment the count using the asset dot update, the value in the service B counter is also updated because both are referencing to the same counter bean in the Spring context. Now here you will be wondering, like, here it is auto-add notation given, but here I have not written the auto-add annotations for the Spring to inject the dependency, because by default, if we have only one constructor in our class and we don't specify the auto-add annotation, it is by default the auto-add annotation, and Spring will inject the dependency into it. So if you have only one constructor, there is no need to write the auto-add annotations. So this is the whole flow. A counter is added to the Spring context, and service A and service B are added to the Spring context, and this same counter is injected in both the services that are using the counter object. So basically there is only one instance of the counter bean exist in the Spring context. So this is the way we can add the Spring This is the way we can add the singleton scope into the Spring context using the stereotype annotations. So let's see. So now you understand that singleton means the single instance. So what the single instance mean? Is it per class, per name? So in Spring, single instance per bin name, per bin name. So if you are aware of the singleton class, singleton pattern of the, if you are aware of the singleton class pattern, in which only one instance per class are allowed. But in Spring, single instance per bin name. It means that we can get the different instance of the same type. It is not per class or not per application. Single instance means that it is per unique per bin name. So let's understand it with the help of, now you will be confused, like this is the where the confusion start. If you are aware of the singleton class pattern in which only one instance of the class is allowed per class, but in the Spring one instance per bin name are allowed. So let's see it with the help of example. So basically, let's say we have a counter, we have counter class. So in the singleton class pattern, we can add only one instance of this counter class into the app's memory. So this is a singleton class pattern. But in the singleton bin scope, we can add many instances of this counter into the Spring context, but the name should be unique. So multiple instances of the same class can be created if the instance have the different name. But here in the singleton pattern, only one instance of class is created. So let's see it with the help of example. So let's say it with the help of example. What is it saying that in singleton scope, single instance per bin name, not per class. So what it's saying that it is the single instance per class, single instance per bin name. Like for example, if the counter 1 is there, then the only one counter will be exist. If counter 2, then only one counter 2 will exist. But the same multiple instance of the same class can be created if the instance have the different name. And you all guys know how we can create the multiple instance of the same class. So this is only possible with the help of @bin method call and not with the stereotype annotation. So let's see both the example with so let's see with the help of example. First we will create the singleton pattern, and then I will create the singleton bin scope, and I will explain you the difference in both the approaches. So first let's come here and create the singleton pattern and create one class named counter singleton, like singleton counter. And what we will do in this, let's say count is equal to 0. And what we will do, since only one instance of the singleton counter can be existed, so no other can be called its constructor, so make its constructor private. And let's print it whenever singleton instance is created. Singleton created. So now we mark the constructor to private so that no method outside this class can call this method. So we need to give the instance back here. So let's create one public method, get and single counter and get instance. So this method will give the instance back to the calling method. So what we will do, first we will check if, and here what we will do, we need to create one variable known as private singleton counter single instance is equals to, by default make it null, and also make it final. And come here and check first if the single instance is equal to null, then we will create it single instance is equals to new singleton counter. If not, then return it. sorry, we can't make it final. Let's return it. Now let's see how we can use it in our main app. So come here, let's comment out this code, and in order to get it, for example, let's singleton counter c1 is equals to singleton counter, and we need to make this method static so that we can call it without creating its object, since we can't create its object. And also make this instance static so that we can access it. Come here and get singleton counter dot get instance, and again singleton counter c2 is equals to singleton counter dot get instance, and let's check whether both are equal or not. Boolean is equal is equals to c1 is equals to c2, and let's print it. Let's run it now. So as you can see that counter is created, only one instance of the counter is created, and whenever we are getting it, c1 and c2 both are equal. So it is a singleton class pattern. So in singleton class pattern, we can only create one instance of a class. We can only create one instance of a class in a singleton class pattern. As you can see that in singleton class counter, we can create only one instance of it. So this is in the singleton class pattern. But in the singleton bean scope, we can create multiple instances of the same class if the beans have the different name. So let's see how we can do this. So first come here counter, and as you all know, we can add the multiple instances of the same class using the bean method call, and cannot add it using the stereotype annotation. So come here and add it using the bean method call. So bean counter. So let's first add counter1 is equals counter1 return counter1, and come here and add another bean of the type counter, and this time let's name it counter2, and here return counter2. Sorry, return counter or not, because sorry, here we need to create the new counter. Return new counter. So now basically what it will do, it will add the two counter of the same type into the Spring context. And let's come here and first let's uncomment it. Uncomment this, and let's what is it, why it's giving error? C1 and C2 is already defined, so let's rename it to the singleton C1 for S, and here let's say S C2 and is as equal singleton equal, and let's S C2 and let's S C2, and let's write it here S. So this is of the type singleton. So first let's come here, singleton pattern. So let's see where is equal is already defined, where is equal. Okay, so let's comment it first, comment it, and let's try to run it. So when we will run it, it will give us error. Why it is giving us error? Because you can see that now we have two counter. Now Spring is getting the ambiguity, like which counter to inject into the service A and which counter to inject in the service B, because by default the counter is of the type singleton, so only one instance can be injected into the Spring context. So only one instance per bean name can be injected. So Now only one instance of the counter 1 and only one instance of the counter 2 is injected into the Spring context. And now the Spring is not able to show that which counter to use here. So let's come here and specify explicitly with the help of counter qualifier, and let's name it to the counter 1, and in the service B let's name it to the, come here and name it here counter 2. And let's now come to the main.java, and let's first comment this out, singleton pattern, and run only this service. It is creating one, getting the service and checking both the counter variable, if both the counter dependency are same or not. So now both the C1 service A and service B will have the different counter, so it will give us the false. So as you can see that the two instances of the same class is created. One is of the name counter and one is the name of the counter 2. Now in both the service A and service B, different counter is injected. In this, the counter 2 is injected. In this, counter 1 is injected. So if we update the counter of the service A, it will not affect the counter value of the service B, because in both the services different counter is updated. So this is the major difference between the singleton bean scope and the singleton pattern. In the singleton pattern, only one instance of class is created, but in the singleton bean scope, multiple instance of the same class is created if the instance have the different name. As you can see from here, the multiple instance of the same class counter is created. Two instance of the same class counter is created, but it's different name. We cannot add the two instances of the same name into the Spring context. So what's happened here? Here, the two instances of the same counter is added into it now, and the service A and the service B. We need to specify which is to inject. So in service A, we have injected counter 1. In service B, we have injected counter B. That's why if we increment the counter value of the service A, it will not affect the counter value of service B. As you can see from here, we incremented the counter value of service A. Here, service A dot counter dot add to count, we have increased the service value of counter A, but it did not. So it incremented its counter, but the service way counter does not increase. So this is the difference between the singleton class pattern and singleton bean scope. In singleton class, only one instance per class can be created, but in singleton bean scope, multiple instances of the same class is created if the name have, if they have the different name. So what is it? So that's why in Spring, single instance, what does a singleton scope means? Singleton scope means that single instance per bean name, not per class, not per application. We can create as many instances of the single class, but it should have the different bean name. So it is a difference, classic difference between the singleton class pattern and the singleton bean scope. In singleton bean scope, multiple instances of the same class can be created, but in the singleton class pattern, only one instance of a class can be created. I have also given you the example. Now it will be clear to you. So now what is the, so let's see a difference between the singleton pattern and the singleton bean scope. So in the singleton pattern, class pattern, only one instance of a class can be created per app, but in the singleton bean scope, one instance per bean name. Like example, for example, we have added the counter 1 bean to the Spring scope, then we cannot get another counter 1. In the singleton pattern, class control its creation. As you can see, a singleton pattern where it's gone, singleton pattern, singleton counter, the class is controlling its object creation using the, by making it private and giving it the instance. So who control the creation of the instance? Class control the object creation. But in this singleton bean scope, Spring controls it. In the singleton pattern, the flexibility is low because we can create only one instance. But in the singleton bean scope, the flexibility is high. Multiple objects of the same class cannot be created in the singleton pattern, but in the singleton bean scope, multiple beans of the same class can be created. It should have the different name. and when we inject it, we need to explicitly specify which instance we want to inject in the service. So Singleton is a default scope. Singleton is a default scope in the Spring. 90% of the bean we write in the Spring, 90% of the bean that we write in the Spring is Singleton by default. So that's become very crucial to understand the working of the Singleton bean in a great detail. So misunderstanding the Singleton leads to unexpected shared state, thread safety issue, wrong assumption from the design pattern. So we need to clearly understand how does the Singleton bean scopes work. So let's see how the Singleton bean work and what is its life cycle. So let's see how does the Singleton pattern work and what is its life cycle. So let's see it in great detail. So what does it mean? Understanding Singleton pattern means that understanding Spring itself. So if we understand the Singleton bean, it means that we have understand the Spring itself. So let's see how we can understand. So let's see the bean life cycle of the Singleton bean. What is the life cycle of the Singleton bean scopes? So let's start. So first see what is the bean life cycle. So bean life cycle is, for example, we human have a life cycle like we birth as a child, then we grow and then become old and then we become dead. So this is our life cycle. So like in a similar way, the bean has also a life cycle. So what is the life cycle mean? Bean life cycle is the complete journey of a spring bean from the creation to the destruction, and which is managed by the spring container, or the spring container means the spring context. So what is the bean life cycle? Bean life cycle is the complete journey of a spring beans from the creation to the destruction. As we human or any living being have a life cycle, in a similar way, bean has also a life cycle. So what is mean by the bean life cycle? Bean life cycle is the complete journey of a spring bean from the creation to the destruction, and it is managed by the spring container. So every bean managed by the spring follows a life cycle. So every bean that is managed by the spring follow a life cycle. Every bean managed by the spring follow a life cycle. So let's see what is the life cycle of the spring bean. So in high level phases, we can see that, for example, in our human being, we have like phases like child, teenager, youth, old, and so these are the different phases of our as a human being. So in a similar way, the bean has also a life cycle. For example, first the container is started, second bean is instantiated, third dependency is injected, fourth initialization, fifth being ready, sixth business log, and seventh destruction. From here you can see first container is started, bean is instantiated, dependencies are injected, custom init or post constructor is called, bean is ready, custom utility or business logic is called, and custom destroy or pre-destroy is called. So let's see it one by one. Let's see each of the phases in one by one in detail. So let's see first. So let's first start with the what happened when the container is started. So what first in the first phase what happened? So in the first page, when the container is started, spring application context is created. So what happened in the container started? So spring context is created in here. Spring context is created now at this time this is empty. So at this time this is empty. So what happened? First the container is started, and at this phase the container spring context is empty. Now in the second part, it scan the class path scanning start, like when we write the component scan. So in this it will scan all the classes available and the given package and search for any class that is marked with the annotations like stereotype annotations, and add all the bean definitions, and bean definition it will read the bean definition. So what happened in the first page? In the first page, the container started, empty spring context is created, and with the help of the component scan, with the that we write, for example here, you can come here and see here we write the component scan base packages, it go to this package and scan all the classes and see all the classes that are marked with stereotype annotations. So it will read all the bean definitions of all these classes that are marked with a stereotype annotation. So this happened in this container started phase. Important. In this phase, no object is created, only metadata is prepared. So what happened in this phase? In this phase, Spring context is created and the metadata is read. Metadata of all the component is read and all the method that are marked with the bean annotations in the project configuration are read. So in this phase, no object is created yet, only metadata is prepared. So we can think this phase as a planning phase, like this is the planning phase. So now let's see what happened in the bean instantiated. So what happened here? Now here the Spring tries to create the bean, it will create the bean and add to the Spring context, and how it can create the bean. So it create the bean with the help by calling the constructor, and but here the object exists but is incomplete if there is some dependency into it and it is injected with the help of field injection or setter function. Then in this phase the object is created and added to the Spring context, but still it is incomplete because till now the dependency is not injected into it. So what we should not do? So we should not use the dependencies here or write the business logic here in the constructor. So what happened in the bean instantiated phase? In the bean instantiated phase, Spring create the bean object. Constructor is called, object exists but is in complete state. Because why? Because the object is created, but if we do the injection with the help of field injection or setter injection, the dependency is not injected till now. So that's why object exists but is incomplete in the phase, in the bean instantiated phase. So let's see what happened in third phase. So in the third phase, Spring inject the required dependency into our object. Spring inject the required dependency and it happens to the constructor injection, setter injection, field injection. So, but you guys were wondering, like we have read that in the constructor injection. So in case of constructor injection, dependency are resolved and injected during instantiation. So if we do the injection with the help of constructor injection, so these two phases are combined into the one phase. And both the dependency resolution or injected happen in the same phase, being instantiated phase. But in other injection type, like for example in the setter and the field injection, dependencies are injected after the instantiation. For example, in the case of constructor injection, the Spring tried to create the bean and add to the Spring context, but it see that there is a dependency. So first it create the dependency and add it to the Spring context, and then it will inject the dependency and then add to the Spring context. But in case of field injection, first the object is created, and after the object creation the dependencies are injected. So in the field and the setter injection, these two are of the different phase, but in the constructor injection both these phases are combined into one and happen at once at an atomic way. That's why the constructor injection are preferred as compared to field injection, because object always exists in the complete state and there is not any ambiguity. But in case of field or setter injection, there is an object exists in the incomplete state. We can see it with the help of example. Come here and let's come here and see. Currently it is working fine, but let's say we come to the service A, and what we will do, we will do it with the help of, now we will do the injection with the, let's uncomment it, and let's say we are not injecting with the help of constructor injection, we are injecting with the help of field injection. So come here, first mark it auto add and specify which one to inject here. So with the help of qualifier, let's say we want to inject the counter 1 into it, and this counter 1, now the construct, now what happened here, first the object is created, now the object is created and after dependency is injected into it. For example, if we run it, it's giving us the correct option, the dependencies are injected into it. But since the object exists in the incomplete state, and if we try to use the dependency in the constructor, it will give us the error. For example, counter dot get count, let's say we try to get the count and let's try to print it during the object creation, and let's run it. Now it will give us error. As you can see here, it will give us the null pointer error. As you can see from here, counter dot get count, because this dot counter is null, because here first the object is created, so what happened in the field injection, first the object is created using the constructor, and after that the dependencies are injected. So it tries to call this constructor and tries to add to the spring context. So at this time, this is going to be the null, because after the object creation the dependencies are injected and we are accessing this null to get the count. That's why we are getting the null pointer error, because both these two are of the different phases. Because in case of constructor injection, setter injection, these two are of different phases, but in case of the constructor injection, both these are the same dependency are resolved and then injected during instantiation. So but in case of constructor injection, first the dependency are resolved and added to the spring context and then injected, and then the object is created. So you can see from here, if we come here and write counter and here this dot counter is equals to counter, and we remove it auto add annotation from here, at the rate qualifier counter 1, and if we run it, and let's mark the auto add for the verbose, and now if we run it, now it will not give us the error, because both are combined into one step. So in the constructor injection, both state are combined into one, but in case of the field and the setter injection, both these are the different phases. Now after the bean instantiation, after the bean is created, so in the third phase is the custom init or post construct method. So this is the first phase, second phase, third phase. Now at this phase, what happened till now, this phase, the bean is created and added to the spring context. Now in the fourth phase, custom init method or post construct method are called. So what happened here, perform one time logic after the dependencies are ready. So what is happened, it performed the one time setup logic after the dependencies are ready. So what is its real world use cases, like opening a database connection, loading the cache, validating the configuration, or starting a thread. So after the dependency are injected, the post construct method are called, or the custom init method are called. Let's see how it is. And this is one of the most important lifecycle hook. Which one is the post construct method or custom init method? So it is used to perform the one time setup logic after the dependencies are ready. So after the dependencies are ready, it is used to perform the one time setup logic. So let's see how. So in the first step, the context is started, the spring context is created, it is empty. In the second phase, the bean is instantiated and added to the spring context, but it is currently in an incomplete state if it happens through the field or the setter injection. And the third step, the dependencies are injected into this bean, and the now bean is fully functional. After the step 3, the bean is fully functional. So after third step, in the fourth step, it is used to perform the perform the one-time logic using the custom init method or the post construct annotations. So in this, it is used to perform one-time logic. So let's see what is it with the help of example. So come here and the counter, let's say, so let's create one method like let's say void, let's name it to like open db connection. For suppose our counter depend on the db, so open db connection, and let's print it. See out db connection is db connection opened. So and how we can, so this is method is created. Now how we can call this method? So we can call this method this we don't call this method, the Spring call this method for us. So we need to come here and specify in here like, so first let's come here and do one thing like come to the project configuration, and what we will do now, come here, now add only one instance to it, remove it, and come to the service B, remove this qualifier from here, and come here and remove this qualifier from here also. Now there is only one instance of the bin exist. Now come to the project configuration and add, come here and add here init method, and write here open, what was the name of this method that we have created, to open db connection, copy it and pass it into this init method. So now what it will do, after the bin is ready, it will call this method. So first the dependency are inject, first it will be created, or it's, so first see here only, as you can see here, first the counter is created, is opened, and after that this method is created just after the object is created, and then the service A is created and service B is created, is printed. So this we can call the custom with the help of init method. So this we can call with the help of custom init method. This is just created after the dependencies are injected, but currently our counter doesn't have any dependency, so this phase, third phase, is skipped into this. But if we add the custom init method in the service class, then it will be called. But it is happened with, we are adding it to the Spring context using a stereotype annotation, so we cannot come to the project configuration and add here like init method. So in this case, for the stereotype annotation, we have to use the annotations for the configuration for the post. So what annotations we need to use? So we need to use the post constructors. So currently you can see that there is not any post construction annotation is available, so we need to add it to our dependency first. So come to the pom.xml and add one dependency to it named as, let's add it dependency, and come here and Java X annotation API and add it here. So we need to add it Java X.annotation API in order to use it. So we have added the annotations, and now come to the service A class service, and let's add now post construct. Now you can see that it is not given. So, and let's add here one method name void open db connection, yeah, or let's say perform initialization, and add here, and let's add here SOUT performing initialization in service B, like opening db connection. Let's come to the app.java and let's run it. So now you can see here, it's now giving us like after the counter is created, then the performing initialization in service B in db connection, and it happened after the object is created. We can verify it. like come to the service B and come to the constructor and add here like cs out to come here and write service B is created. And let's come to the app.java. Basically service B printed, and it will work, but for the after dependency is injected, come here and type here. Let's now run it. Now first the service B is created, then this method will be called. So as you can see here, first the counter is created, then the post construct of this method, a custom init method of this counter is called. How it is called? Because we come to the project configuration and we specify the custom init method, and then the service B is created and the dependencies are injected into this, and then after this post construct method is called, and this is used to perform one-time logic, as you can see here, performing initialization service B. And this post construct annotation is used to mark this post construct method is used for custom instead of custom init method, because we are using the annotation based configuration. So in the annotation based configuration we need to use this post construct method. So this is of the post construct method, and this is one of the most important lifecycle callback hook that is used to perform one-time logic. Now you will be wondering like, why can't we do the initialization in the constructor part, and why there is need of the another custom init or post construct method? Because in the constructor field, if we do the injection with the help of field injection or setter injection, then the dependency are not ready in the constructor. As we have seen in the previous example, it will give us the null pointer error. So basically, if we want to do the injection with the help of class construct, with the help of setter injection or field injection, and we want to use the dependencies, so this lifecycle hook is best, because at this point our bean is completely ready after the dependency injection. So that's why it is best time to do this. Now so in the third phase, first the container is started, second the bean is instantiated, third dependency is injected, fourth the post construct method is called. After this the bean is fully ready and fully initialized. So bean is so what happened after this? After this the bean is stored in the Spring context, and the bean is now fully functional and can be used in our applications. So it is safe to use in our application. After this we can call the custom utility method on our business logic. So now normal application code runs. For example, as you can see here, after this we called our method like update method, this is our business logic, or like check, all this normal method can be run like normal. So normal in the fetch 6, our custom utility method, or it is our business code that will run. And in the last phase, so this is not a part of the lifecycle, this is the runtime usage that we will use in our application for it. So in the last phase, custom destroy or pre-destroy method. So why it is called? So it is the last phase of the bean lifecycle. This is the last phase of the bean lifecycle. And what is it? It is the last phase. It is the last phase of the bean lifecycle. So let's see what is it. So in this phase, our bean is destroyed. And the application shuts down. So what happened here? First the context is closing. So when the context is closing, so here is our context, Spring context, and it will close. So all the bean in it will be destroyed. So Spring calls the destroy callback. And now, so Spring will call any method that is marked with pre-destroy, or any method that are marked with the destroy in the project configuration class. And why it is used? It is used for clean up the resources. For example, in the pre-destroy, in the post construct method, if we have open any DB connection, so we need to close this DB connection. So it is used to clean up the resources. So for example, it is used to do like cleaning the resources, like it is used to close the DB connection, stop the threads, and flush the logs. So all these methods are, all this is the real world use cases of the custom destroy or pre-destroy methods. It is used to perform the cleanup resources. For example, if we don't close the DB connection, then our DB server can become overwhelmed with number of connection, and after several time it will stop accepting the new connection, because it will, if the connection is not stopped, it will assume that the client is currently using our my DB connection and allocate some resources to it. So if the multiple connection is open, like if many connections like 500 or 1000 connections is open, and after that it will not accept any more connection. So that's why the cleanup resources is necessary, and it is happen in the pre-destroy methods or the custom destroy method. So let's see how we can specify the custom destroy methods and when it will be called. So come here and let's first come to our counter, and let's here say void cleanup. So what it will do, it will do the cleanup, and what it will do, cleanup, and let's say it is closing the DB connection, closing DB connection. And how we can call this method? So we will come here and we will write here init method, and then we will come here and type destroy method. And what is the name of the method? So the name of the method is cleanup. Come here, come to the project configuration and type here cleanup. Now come to our app.java and run it. So run it. Now you can see here our first the counter is created. After that the pre-destroy method is called, then the service is created, then so for the more verbose message, let's come here and what we will do right here, post construct is called, post construct or custom init, and let's here let's custom destroy called, and let's come to the service class and write here service p, and where is the post construct method? Let's come here and write @ post construct is called, and let's come to our app, and now it will give us the more verbose message. So as you can here see, for the counter is created and its post construct method is called and DB connection is open, then our service B is created and its post construct method is called, then our normal business application logic runs. But why does our this method, why does our let me close this. So now you will be what now, but why does our cleanup method or the pre-destroy method is not calling in the project configuration? We have marked our destroy method here, we have written the here we have written the cleanup method, and here we have specified our destroy method. Still it is not showing because we haven't closed our context, and this method is called just before the context is closing, because this method is called just before the context is closing, but in our application the context is not closed still, so that's why this method is not called. So if we come here and if we write context.close, now our pre-destroy method will run. Now you can see here custom destroy is called and cleanup closing the DB connection. So because our custom destroy method is called just before the context is closing, as you can see here it is called just before the context is closing, and if we write something here it will be printed after this, after custom @ post pre-destroy. destroy. Now you can see, so you can see the context is closing here. So just before this custom destroy method is called, and after this this line is printed. So after customer pre-destroy. So this is the post destroy, and why it is used? It is used for cleaning the resources. But if we have defined our bean using the stereotype annotations, then how we can add the post construct method? So it's very easy. Come here and let's copy our this method cleanup method from here and paste it in our the service class, and let's write here post construct is called a pre-destroy called, and what we need to do, we need to come here and write here pre-destroy, and let's come here and let's run it. As you can see here, now it's called pre-destroy method is called cleanup closing the DB connections, and the custom destroy method called closing the DB connections. So this is of the service B and this is of the counter variable. So this is the whole flow of the life cycle of the bean. Now there is one confusion that we will be wondering, like what happened when we come here and we we come here and write cleanup to void cleanup, let's say in the bean that we have created using the bean method call, and in this if we write, let's say it is a cleanup to custom, and let's write here @ post construct, oh sorry, pre-destroy of counter and custom destroy of, let's say, counter, and let's say we marked it with the post construct pre-destroy, pre-destroy, and let's see which will be run first, because it and this is with the help of the stereotype annotation based, and this is with the help of project configuration. We have specified the destroy method cleanup, and in the counter what we have done, we have also marked the pre-destroy. Then which will be printed first? Let's see. So as you can see here, first the pre-destroy of the counter is called, then the custom destroy of the counter is called. So if we have specified both the custom destroy method, so here if we have specified both the custom destroy and pre-destroy, for example, if we have specified both pre-destroy and the custom destroy, so first the stereotype will be called, then the custom destroy method will be called, and that is the same for the custom init. So the flow is like first the post construct called and then custom init called, and here also first pre-destroy will be called and then the custom destroy will be called. So this is the flow. If we have specified both with the annotation based and custom init, first the annotation based method will be called and then the custom init method will be called. Same in the case of the first the pre-destroy method will be called and then the custom destroy method will be called if we have specified both. So this completed our whole life cycle of the Spring Bean. And there is one note that this pre-destroy method is only called for the Singleton bean, because in the prototype bean the Spring does not manage the life cycle of the bean. In case of prototype bean, after returning, the Spring forgets about it. We will learn it in detail in the prototype section, but keep in mind that the pre-destroy method is not called in the prototype bean, and it is the developer's responsibility to write the manual cleanup code. So now you will be wondering, like, what is the best practice to where to write what? So it is a whole flow. So in the constructor, you should write the object creation logic. Object creation logic should be written in the constructor. In the post construct method, setup and initialization should be done. business method. In the business method, application logic should be run, and the pre-destroy, cleanup and resource releases should be done in the pre-destroy method. So this is the summary of where to write what. In the constructor, we should write the object creation logic. In the post construct, we should do the setup and initialization. In the business methods, we should do the application logic, and the pre-destroy, we should write the cleanup and the resource release code. So this is the best practices to. Till now we have learned about the singleton bin, and what is singleton bin. Now let's see where should we use the singleton bin and where we should avoid using the singleton bin. Since singleton beans now, so what is the singleton bin? So the singleton bin is shared across the applications, and multiple component and multiple thread uses the same instance. That's why we shouldn't use any state. We should not modify any state of the singleton bean, because so therefore it is best suited for the service classes and business logics, and not for any component that is holding any state or modifying any states. So it is critical role. So first, the singleton bean should be immutable. In this, there should not be any modification should be done. It should be immutable. So final allowed, what is allowed? Final fields, constants or injected dependencies are allowed, but avoid changing the field during the method execution. Why? Because web applications are multi-threaded, and if multiple thread access the same singleton object, suppose multiple thread T1, T2 access the same singleton object, then and if this both the and if there is a mutable state in the singleton bean, then it will lead to the danger and lead to the race condition and some data corruptions. So that's why the singleton bean should be immutable. It should not be modified during the method execution, because therefore it should be stateless. The singleton bean should be stateless, like it should hold the state. If it want to hold the state, it should hold, but it should be constant. It should not be modified. Like final fields, constant and injected dependencies are allowed, but it should not modify during the method execution. Why? Because web applications are multi-threaded and multiple threads access the same object, and if there is some if the mutation or the object is updated, then both the T1 and T2 can update the object and lead to the race condition. Let's see it in a great detail. Let's see what is the problem with the mutable singleton bean and what is the race condition. Mutable singleton bean and what is the race condition. So first see what is the race condition. So consider, so when does the race condition occur? When multiple thread access the same object. So for example, consider we have two threads T1 and T2, thread 1 and thread 2, and these two thread access the same object, let's say counter, and both the threads tries to modify the shared data. Consider it has a shared data, let's say count is equal to 0, and both the thread T1 and T2 tries to modify this shared data, then it leads to the race condition. So what happens? What is race condition? Race condition occur when multiple thread access the same object. Here in this case we have a counter object, and there is a shared object counter, and it has one field that is shared, count is equal to 0, and if both the threads tries to modify the shared data, then it leads to unexpected output and data corruption. So let's see it with the help of an example. So currently we have this. So what we will do, so first let's come here and let's comment out all this code. Let's comment this code, come here, and let's write it for the counter, explaining the race condition. So what we will do, so here is our counter object, here is our counter class, and in this let's And now we have, let's remove it, like all this, let's comment it out. And what we will do, come to the project configuration and remove this also, unless, because it will give us error. And now come to the app.java and do one thing, let's remove all this code. So now it become clean. Now what we will do, and let's close this and come here, do one thing, remove the service annotations from here and the service B also. So now we will focus only on our counter object. Let's forget it. Let's remove it, remove pom.xml also. So now what we will do, now we will understand the what is the race condition. So race condition, when does the race condition happen? When multiple thread tries to access the same object and try to modify the shared data. So currently we have our counter object, and in this there is one first let's clean it also. So now let's clean it. So currently what we have our counter object, and we have added its instance to our Spring context, and by default it is of type singleton because we haven't specified any scope. Now let's see. Now it has one, it is a type, it is a mutable because this object is mutable because it is holding a state and it is modified it during the execution. So it is a mutable object. Now let's see why the mutable singleton object is of the topic of the concern, and we should not use singleton object with the and we should not use mutable object with the singleton scope. So what we will do, so let's create the two threads that are accessing the singleton object. So what we will do, so first create runnable. Now in order to create the thread we need to implement the runnable interface. So there are two ways. First we are using with the help of the anonymous class, or we can also use the functional interface. So let's first name is task, let's name is thread 1, and what we will do, let's say new runnable. We are doing it with the help of anonymous class so that it will be easier for you to understand it. And what we will do, here we will get one instance of the counter c1 is equals to context dot get bean, and let's say counter dot class. Now what we will do, let's increment it for int I is equal to 0, I less than 100,000, and I plus plus, and let's increment the count c1 dot add to count. Okay, it will, and let's run it, and let's implement another runnable. Let's copy it, and let's name it thread 2, and let's say it's c2, and let's add c2. Okay, now it's fine. Now we have created the two thread. Now in order to start it we need to use the thread class. Thread t1 is equals to new thread, and we need to pass the here, let's say thread 1, and for the thread 2, thread t2, we need new thread, and here thread 2. And now let's start both the thread t1 dot start, and let's t2 dot start, and let's wait for both the threads to end, t1 dot join and t2 dot join, and here catch, it will throw the interrupted exception e. So let's catch it, exception occurred. And finally, after the execution, let's print the count value. Let's say we get the same instance counter c is equals to context dot get bean counter dot class, and let's print its count c dot get count. So what we have done here, let's understand. So basically we have created the two threads by implementing the runnable class. We have implemented a two thread and override this run method, and by default the thread, this run method will be called. And we have created a two thread t1 and t2, and also we have created two threads and t1 and t2, and we have started this thread now t1, and with the help of join we are telling the main thread to wait for the completion of both the threads, and this join method throws the interrupted exception, and it is a checked exception. That's why we have to catch it. And finally we are checking what is the now currently the value of the count, and let's run it. So as you can see, every time when we run it, we will get the different output. As you can see here, we are getting 1702. Again we will run, we will get 1531. Again we will run, we are getting the different value. Why? But we are not changing any code. So what it is doing, that it is incrementing the first thread is incrementing the count to the 1000, and the second thread is incrementing the count by 1000. So if it is work as expected, so finally both the thread t1 is incrementing the 1000 count, and t2 is also incrementing the 1000 count. So at finally we should have 2000 count value should be 2000. But as you can see here, we are getting the different outputs. 1674. Again we will run, we will get the different output. 1820. Again we will run, we will get the different output. 1857. So why it is happening? It is happening because multiple thread tries to modify the shared data, and due to this there is unexpected output and data corruption. Why? Because suppose currently we have count value is equal to 0, and both the thread t1 and t2 come here, and t1 so let's see what is happening here. So first now both the t1 and t2 accessing this count value is equal to 0. So in order to access it, this is a third step process, 3 step. First it will read the current value of count, then it will increment the count, and third it will add right back to the count. So the incrementing the count is of 3 steps. So suppose t1 come and read the t1 of 0, count is equal to 0, t2 and its count value, the count value is equal to 0, count value is equal to 0. Incremented the count become 1, it also increment the count 1 and write it back 1 and 1. So it incremented the count by 1, t2 also incremented the count by 1, but both happen concurrently at the same time, as a resultant of which the count is incremented by 1 only, but it should happen by 2. So this is the rest condition. Both try to modify the shared data at the same time. This leads to the unexpected output and data corruption. As you can see here, it's giving 1857. So what happened is that 1857. So basically 143 times this condition happens. Both T1 and T2 tries to modify the same data, and 143 times it leads to the loss of one count. So that's why it is not recommended to use the mutable state in the singleton scope type. Therefore singleton bean must be immutable. And we should not use any mutable thing in the singleton bean. Because why? Because it leads to the race condition and it leads to the data corruption and unexpected output. As you can see here, we are not getting the expected output of 2000. We are getting unexpected. Every time we will get different output. So that's why it is unexpected. So So what is the best practice to follow in the singleton beans? So best practice is immutable singleton bean with the constructor dependency injection. So first, if we have singleton bean, then we should make it immutable, and we should also use the constructor. And if it has some dependency, we should inject the dependency with the help of constructor dependency injection, because with the help of constructor dependency injection, the object become its dependency become immutable, because we can use the final keyword with it. So why constructor injection is because it enables immutability, because we can use the final keyword with the dependency, and that's why it cannot be modified later. But in the case of field or setter injection, we cannot mark the field as final. I have covered it in great detail in my dependency injection video. You can go and watch that video. And that's why the state cannot change after creation. There was thread safe by design. Therefore, we should make our singleton bean scope immutable. And how we can do this? With the help of constructor. If we have dependency, we can make it with the help of construction injection. And if we have any local variables, then we should not modify it during the method execution. And we should also ensure that our singleton bean should be immutable and should not hold any stack. This is the best practice to follow. Now, till now we have learned about the singleton bean, how we can create it, its life cycles. But there are two methods of initialization of the singleton bean. One is the eager and one is the lazy. So let's start. So let's say by default the Spring follow the eager initialization. So what is meant by the eager initialization? So eager initialization by default is the default behavior. So by default, Spring creates all singleton bean at the context startup itself. Even if the bean is never used, then the Spring create the bean at the context startup, and this behavior is called eager instantiation. Now, by default, Spring create all the singleton bean using the eager instantiation. What is meant by the eager instantiation? So the Spring creates the bean at this context startup. What is meant by the eager instantiation? At the name specify eager. So by default, Spring create the bean at this context startup, even if the bean is never used. So this behavior is called the eager instantiation. So let's see it with the help of one example. So currently we have our counter bean, and in the app.java, let's remove this. So now you have understand how. So let's remove this. So now you can see that we haven't used our bean anywhere in our program, and let's run this program. You can see that we haven't used this counter bean anywhere in our project or program. For example, we haven't used because we unmarked this service annotation, so we haven't used our counter object anywhere in our program. Still, the Spring creates it at the context startup and add it to the Spring context. As you can see here, context is started and the Spring added the bean at the Spring context by default. So this behavior is known as eager instantiation. You can see that even though the counter is never used, Spring still creates it and console's output appear at the startup, as you can see here. So this is known as eager instantiation. So what happens in eager instantiation? Spring prepares everything upfront. Now let's see what is meant by the lazy instantiation. So as the name signifies, lazy instantiation. So you can guess it. Like with lazy instantiation, Spring does not create the bean at the startup. Bean is created only when first requested. So with the lazy instantiation, Spring does not create the bean at the startup. It only creates when it is first requested. We can see it from here. So what is the syntax for it? So we can see it from here. So let's come here, and in order to mark any bean as lazy, follow the lazy instantiation, go to this, and after this mark it as lazy. Now run it. Now you can see that the count, this is not called, this is not printed. It means that the till now the counter bean is not created. So let's print it here. Before creating the counter, and let's first use it in our program. C1 is equals to context dot get bean counter dot class, and let's print it. After creating the bean, and let's now run it. So as you can see that the counter is created, the counter instance is created after it is first requested. As you can say, first the before creating the counter is printed first, then then we requested it from the Spring context, then it creates it, and then after it, after creating the bin is printed. So with what happened with lazy instantiation, Spring does not create bean at the startup. Bean is created only when it is first requested. So this happened with the help with the lazy instantiation. This happened. So now let's see. Now let's see when to use what and what is the advantages of using both of these approaches. So by default, eager instantiation is recommended and it is default. So why it is recommended? Because beans are ready before execution start, and it gives us the better runtime performance as compared to the lazy instantiation. And if there is any error in the bin, then it is detected at the Spring startup only. So this is best suited for most applications, web apps and microservices. It is best suited and it is recommended and default. And lazy instantiation, we need to be careful before using the lazy instantiation, because there is one advantage of using the lazy instantiation, that it saves the memory if many beans are used. But there are several disadvantages, like slight runtime overhead, because this Spring needs to check if there is not any bean at the context currently before creating it. So there is some time of slight runtime overhead. And second downside is that the error does not appear at the startup, it appears during the execution. So this is some disadvantages of the lazy instantiation, but it is useful if there is a large monolithic applications, and it is used for optional or rarely used feature. We can use this lazy instantiation, but by default in the 90% cases we should use the eager instantiation. So what is the conclusion? Always prefer eager instantiation for your project, and use lazy only when you clearly understand why you need it. Often the need for lazy beans indicate a design problem. So this is the conclusion between the lazy instantiation and the eager instantiation. And what is the difference between all these two? Till now we have learned about the singleton scope. Now let's learn about the prototype scope beans. So before learning about the prototype scope bean, first let's try to understand why do we need prototype scope. So until now we have used the singleton beans. What in the singleton beans, there is one shared instance, there is only one instance of the bean, and it is shared everywhere. But sometimes each request needs a new object, but sometimes there is a requirement that each request needs a new object, and the mutable state is required, and the thread safety become important. But with the help of a singleton scope, all these three requirements cannot be fulfilled. So this is where the prototype scope is useful. So what is prototype scope? So let's learn about what is the prototype scope. So in the case of prototype scope, every time we request a prototype bean, Spring creates a new instance for us. So what is meant by the prototype scope of the bean? So every time we request a prototype bean, Spring creates a new instance. There is not on any single instance stored in the Spring context. It is dynamically, like every time we request a bean, Spring creates one instance of the bean for ourselves. So Spring does not reuse the instance. Spring only manages the type and create a new object on the demand. So let's see it with the help of one example. So, and what is its syntax? And what is its syntax? Its syntax is like in scope, and in the semicolon we need to write, in the double quotes we need to write the scope as prototype, or we can also use the bin definition dot scope prototype. It is basically prototype only. So let's see it in action. So what is the prototype scope? So in case of the prototype scope, every times we request a prototype bin, Spring create a new instance, and after returning the instance, Spring forgets about it. So the Spring does not reuse the instance again and again. So Spring only manages the type and create a new object on demand. We will see the complete life cycle later in this video. So let's first see it with the help of example. So currently we have a counter object, we have a counter class, and we have added it to our Spring context. So in order to define its scope to the prototype, we basically need to write scope and here write prototype. So now it becomes the prototype scope bin. So every time we request a bin, Spring creates a new instance for ourselves. For example, let's see, counter c2 is equals to context dot get bin counter dot class and let's print it. Boolean is equals to c1 is equal to c2, and let's print it is equal, and let's also print its hash value so that we can see that whether it's same or not. SOUT c1 dot hash code, and also let's print it for the c2 also, c2 dot hash code, and now let's run it. So from here we can see that with the first time it requests a bin from the Spring, it created a new instance, counter is created, and second time it requests the bin, the second instance is created, and we also can verify that these two instances are different with the help of its hash code. For the c1 the hash code value is this, and for the c2 the hash code value is this, and since these two are not equal, so we can say that these two counters c1 and c2 are not referencing to the same instance or the reference. Both are different instance. So in case of prototype scope, what happens? In the case of prototypes, the Spring does not reuse the instance. Spring only manages the type and created a new instance on the demand. So every time we request a prototype bin, Spring creates a new instance for ourselves. For example, here we request one instance. So, and suppose we request one more instance, then one more instance will be created. For example, context dot get bin counter dot class, and if we now the three counter object will be created. You can see from here you can see that the three counter is created, three counter is created because we have requested the counter bin from the Spring context 3 times. So what happened in the prototype scope? In the prototype scope, every time we request a prototype bin, Spring creates a new instance for ourselves. So basically what happens? So when we write this line where context is a new application context, so it will first create the blank or empty Spring context, and when the Spring runs, it adds, no, the Spring does not add the counter instance to the Spring context. It only stores the metadata. What does the Spring store at the application startup? It only stores the metadata, like the information required for the creation of the bin, and every time we request a bin, Spring creates a new instance of the bin and return it to our object, and it creates the new instance and return to our object, and after returning it, Spring forgets about it. So we can consider the coffee plant as our prototype. So here it is a coffee plant. So Spring does not manage the context. Spring does not manage the, and this will be always be false. Because why? Because c1 will never be equal to c2, because every time Spring creates a new bin, and these two bins are never going to be the equal, therefore its value are always different, and this value is always going to be the false. So in this way we can declare a prototype scope in our Spring context. So now let's see what is the life cycle flow for the prototype scope beans. So what is this life cycle mean? Life cycle means the complete journey of the bean from the starting to the end, like from the creation to the destruction, the whole life, whole flow. So it basically has the 5 phases. First, the container is started. Second, the bean instantiation. Third, dependency injected. And fourth, initialization. And fifth, return the object or the bean. Let's see each phase in the detail. So let's start with the what happened. Now there's one important thing, like after the Spring returns the bean, Spring forgets about it and does not manage it. We will see it in later in details. Let's see. So first phase is container is started. So when the container is started, like when the Spring container is started, that is Spring context is initialized. Then Spring container is initialized. Initially it is empty. Now the Spring go to the bean definition and it see the prototype scope, and therefore it will add something. But what it will add? So for the Singleton bean, the Spring creates the object immediately. We are considering the eager initialization by default. So by default, the Spring creates the object immediately and stores the actual object instance in the container. So in case of Singleton bean, as soon as the context is created, Spring creates the object immediately and store it in the Spring context. But in case of prototype bean, Spring does not create the object at the startup. Spring only stores the metadata or blueprint. Now Spring does not create the object instance and store it in the Spring context. Spring only stores the blueprint or the metadata of the bean. And so when the Spring start, Spring stores only the metadata like bean name, bean class, bean scopes, and constructor info and dependency metadata. Spring does not store actual object instance and any cached reference to the Spring context. So initially when the container is started, in case of Singleton bean, the object is created and actual object is stored in the Spring context. But in case of prototype bean, actual object is not created. Only the metadata is stored in the Spring context, and this metadata can be seen as the tree that is stored in our Spring context. And every time any new instance is requested, a new instance is created, as you can see from this diagram. This is like this metadata information is stored, and every time a new instance is requested, Spring creates the new instance from it. So what does the Spring store? Spring stores the recipe, not the coffee. Spring only stores the metadata and not the actual bean, and does not manage it. So what does Spring do? Spring only stores the recipe, not the coffee. Recipe in the form of plant, like the metadata, like the bean name, bean class, bean scope, constructor information, dependency metadata. And Spring does not stores the actual object instance as in the case of the Singleton bean. So what happened? So in the first phase, Spring container is started and metadata is stored in our Spring context. And every time when we do like counter c1 is equals to context.getBean counter.class, these fourth phases are run. What phases are run? These four phases are run every time we write this context.getBean counter.class. So what does the Spring do in this phase? So first, Spring look up the bean definition stored in the Spring context, creates the new object. Now create the new object and inject the required dependency in it. And after this, the bean is ready. And after the dependency injected, the Spring calls the post construct method or custom init method for performing the one-time logic or one-time initialization something, as we have seen in the Singleton bean scope. And then it will return the object. So After returning the object, the Spring forgets about it and Spring does not store its actual reference in the Spring context. So every time we do the context.getWin counter.class, Spring first look the begin definition stored in the Spring context, create the new object, inject the required dependency, perform the initialization of the post construct method and return the object. After returning the object, Spring forgets about it and does not track it. And therefore, the no pre-destroy methods are called in the case of prototype bean. In case of prototype bean, no pre-destroy methods are called. So let's see it with the help of example. So let's see it with the help of example. So here is our counter class and we have marked this as prototype, and let's create one init method for the performing the initialization. So let's say public void init. We can name this method anything and let's write it like performing setup, like opening DB connection. And what we will do, we will specify it in our bean and specify the init method as init method. And what is the name of our method in this case? Init. So we will come here and we will write it init. So now we will come here and let's see, run it. So as you can see, we have created 3 instances. So first, the first counter is created and its corresponding init method is called counter is created, performing setup counter is created. So 3 instances are created and the init method are called for each one of this. So as you can see that, so every time when we do this one, so Spring look up the bean definition, create the new object, inject the dependency and call the lifecycle method and return the object. After returning it, Spring forgets about it. For example, now if we write any destroy method, let's write here cleanup code like public void cleanup. Performing cleanup. And let's come here and write here destroy method, and what is the name of our method? Cleanup. And now come here and run it. So now it's not printing. Now you will be wondering like, okay, here we don't write the context dot close. So let's write it and now again run it. Now you can see that the destroy method is not called because it is now, as you can see, this cleanup method is not called. That is, this pre-destroy method does not called in case of prototype. So pre-destroy method are never called. Pre-destroy method are not called. So for example, if we even write it here like @ pre-destroy, still it will not run. So in the case of prototype scope, the pre-destroy methods are never called. So now you will be thinking like, why does the Spring does not track the prototype object? So by typically Spring should track the prototype object and store it in the Spring context. But why does the Spring does not track the prototype object? You will be thinking and you have a doubt. So it is due to because for the prototype scope, unlimited instance of the prototype scope can be created, and tracking the destruction would cause the memory overrun. So that's why the Spring's job ends after the creation, and the Spring does not track the prototype object after its creation. Spring creates it, run its post construct method for the initialization and return it to the calling method. And after returning, the Spring forgets about it. Why it forgets about it and does not track? Because for the prototype scope, unlimited instance can be created, and tracking the destruction would cause memory overhead, and therefore the Spring end its job after the creation. So that's why the Spring does not track the prototype object. So it's our responsibility to create it, and it's our responsibility to do any cleanup operations before destroying it. So what happened? So when we write this, now the Spring container is started, and initially only the metadata or blueprint of the is stored in our Spring context. What does it do at the Spring startup? It only adds the metadata or blueprint to the Spring context, and every time we get write any instance that is getting it. So the Spring first look up the bean definition, create the instance, run the initialization method, and return the bean. And after returning it, Spring forgets about it. Spring does not track it, and after returning it, Spring forgets about it. Therefore, both the C1 and C2 will be referred to the different instance. This is the C1 and this is C2, and both are different. Therefore, it will always be false. So this coffee plant is like the bean metadata, it is like a bean metadata or blueprint for the creation of the object. This order is the get bean, and every time we create a new instance, it's like a new object instance, and the machine does not remember the old cup. So now, till now we have learned how we can create the bean scope using the @bean method call. Now let's see how we can create the bean using the stereotype annotations. How we can create the prototype scope bean using the stereotype annotations. So let's see it. So it's very simple. So basically we have created our two classes, service A and service B. Let's open it and let's mark it as our service, and come here and also mark it service, and come in here counter in the project config, remove this from here and come to the counter class. And what we will do here, we will mark here it's like component, and we will mark it as scope. Will mark its scope as prototype. Now it's become the prototype scope. Now if we come here and let's comment this code, and what we will do, we will create the two instances, service A as A is equals to context dot get bean service A dot class, and the service B as B is equals to context dot get bean service B dot class. And what we will do now, let's store the counter of the C1 in the C1 variable, and CA is equals to SA dot get counter, and let's name it CA, and counter CB is equals to SB dot get counter, and let's see whether it's SOUT. CA is equal to CB, and let's run it. So when we run it, as you can see, the two counter instances created. First counter is created, first the count. So service A and service B both depend on the counter instance, and since the counter is of the type prototype scope, so in both the service A and service B, the new instance of the counter is created and injected into service A and service B. So both the counter of the service A and service B are different. That's why when we run it, we are getting false. Here we can see that CA is equals to B CB, and both the counter are different. That's why it's printing false. And for example, we can also verify it like if we run it SA dot update. If we update the counter of the SA, and if we try to check the counter of the SB, let's see what happened. Here you can see that the service A is incremented the counter to 1. The count of the service A is incremented to 0. But still the count of the service B is 0, because both the services different instance of the counter is injected in both the service A and the service B. So let's see it with the help of in the diagram. So what happened when we write? So here, when we write the component and mark it as the scope is prototype, so what does the Spring does? Spring only adds the metadata to the Spring context, and whenever here there is a like dependency injection. So the Spring will create the new instance and add the dependency into here, and again in the service A there is a need of dependency of counter, so the Spring inject the create the new dependency and injected here. So in both the service A and service B there is a different counter. That's why when we updated the counter of the service A, it does not reflect the count reflecting in the service of the counter of the service B, because both service A and service B has different counter instance. So it is in the case of prototype scope. We compared the dependency to prove that the Spring injected the same instance. So it is not true. It is true for the Singleton scope. In the Singleton scope, in both the places the same instance are injected, but in the case of prototype scope, in both the services the different instances are injected. That's why here we are getting false, and here we updated the counter of the service A, and its counter is incremented to A, but if we check the counter of the service B, it's still 0. So that's the case. This is the way we declare the prototype bean using the stereotype annotations. So now you will be wondering like, okay, now I have gotten like what is the prototype scope bean, how we can declare the prototype scope bean using the bean method and the stereotype annotation. Now where should we use the prototype beans? Now you will be thinking like, okay, now where should we use the prototype bean scope? So in the prototype beans create a new instance on every request. So every time we request a prototype bean from the Spring context, Spring creates a new bean for ourselves. So each component gets its own independent object. So no instance is shared across the component or the thread. That's why it becomes the thread safe. So therefore it is best for holding the state or user specific data, task specific or short lived object that changes the state during the execution. As we have seen earlier, the Singleton bean are not useful for the object that changes during the execution, but prototype beans are suitable for the object that changes its state during the execution, and prototype beans can be used for the stateful objects. So from here we can say that the prototype beans can be mutable because each thread gets its own instance, and therefore it becomes the thread safe by default. So where we can use the prototype scope? So the prototype scope can be used in many cases like report generation, shopping cart, or file processor, shopping cart, report generator, because each user request will need a new report generator, and it will have some state like page generated. So the page, for suppose user A requested a request generator, report generation, and user B also request the report generation. So both get the different instance and both managing the state like how many pages are generated for each of them. So this is the classic case of where we can use our prototype scope beans. So if we can use the prototype scope beans where there is a stateful object. So the report generation holds the state like how many pages are generated. The shopping cart stores the state for the particular user like how many items are added for each user and what is its total value. And for the file processor, each file processor holds a specific state for particular files. So the prototype scopes beans are useful for holding the stateful object or user specific data and object that changes its state during the execution. So prototype scopes are useful for this. But here is one important point like, the Spring forgets about the prototype bean after its creation and when it's written it. So cleanup is the developer's responsibility. Now let's see whether there is a race condition in the prototype scope beans or not. So the Spring, no, there is no race condition in the prototype scope bean. Why? Because Spring does not store a single instance. Spring only stores the metadata that is recipe for the creation of the bean, and every time anyone requests a bean from the Spring context, Spring create the new instance and return it, and after returning it, Spring forgets about it. So Spring only know how to create the object, and it does not store any object. So caller get a fresh object each time. So due to this, there is no shared mutable state, and therefore there is no rest condition, because there is no every thread, like for example thread T1 and T2, both are getting the different instance. So there is no shared state, and since there is no shared state, therefore there is no rest condition. So there is a predictable behavior. So if the thread 1 is modifying its data, it is only visible to the thread 1 and no other thread can interfere with it, because every thread will get its own instance. So the prototype scope bin is thread safe by design. Therefore, the prototype bin can be mutable. We can see it with the help of example. Let's see. Let's come here and let's see with the help of example that we have implemented earlier. So come here, we'll remove this. Now come here, create the runnable thread 1 is equals to new runnable, and here what we will do now, here we will get, let's say, counter c1 is equals to new counter, and what we will do, for int I is equal to 0, I less than 1000, I plus plus, and what we will do, we will do c1 dot add to count. And now what we will do, come here, now here we will write it thread 2, and let's say it's c2, and we will not create it. This is wrong. We will request it from the string context dot get bean counter dot class, and here also we will get it from the class context dot get bean counter dot class, and here we will add increment the count to c2. And now what we will do, we will create the two threads, thread t1 using this thread t1 is equal to new thread 1, and thread t2 is equals to new thread 2. And what we will do, now we will try, first we will start it t1 dot start and t2 dot start, and what we will do, we will wait the main thread for the completion of the t1 and t2. So t1 dot join and t2 dot join, and we will capture it. The join can throw join throw an interrupted exception, so we will catch it. And now what we will do, but this c1 and c2 are declared inside this context, so we can't access its value. So what we will do, we will declare it's outside it, so that we can access its value. Or let's say counter c2, and let's get it from the, and let's print its value like c2 dot get count and c1 dot get count, and also let's get a new counter c3 is equals to context dot get bean counter dot class, and let's come here, write it here, and let's print it c3 dot get count. And what we will do, we will come here and write like C1 count. Here, come here and write C2 count, and here, come here and write C3 count. So what we have done here, we have created the first instance of the counter, and we have created a thread using the counter one, and start the thread 1 and the thread 2 and the two different counter, and the counter has one object that is mutable. With the help of this add to count, we are changing its state using the add to count, and let's see whether there is a race condition in this or not. So from here you can see that the three instance of the counter is created. Why? Because here there is C1, C2 and C3. Therefore, every time we request a prototype bean from the Spring, it creates a new bean for ourselves. Therefore, three instances are created. Now the thread T1 working on the counter C1, thread T2 working on the counter C2, and the C3 has value 0. Therefore, there is no race condition in this, and this is thread safe by default. As you can see, this C2 count is 1000, C1 count is 1000, and C3 count is 0, because C1 there is for loop runs for 1010, and its value increases, the value of C2 is increases, and the value of C3 is 0 by default, because its new instance is created. So we have seen that using the prototype bean, we can avoid the race condition, because every thread will get the new instance. Therefore, it avoids the race condition. This thread gets the new instance, therefore it can avoid the race condition. Now let's see a difference between the prototype bean and the singleton bean, and let's end this video. So what is the difference between the singleton bean and the prototype scope bean? So in the case of the singleton bean, if we are talking about the default behavior, like that is eager instantiation. So for the prototype bean, it is instantiated at the startup, but the prototype bean, it does not instantiate at the startup. It is instantiated when the Spring request, when anyone requests the prototype scope bean from the Spring, then it's created, and for each request, Spring creates a new instance and forgets about it. Now in case of the singleton bean, new instance per request, no, the same instance is shared across every request. But in case of prototype scope, the new instance is created per request. In both the singleton bean and prototype scope bean, the dependency is injected. In both of singleton and the prototype scope, post construct method is called, but the pre-destroy method is not called in the prototype scope, but it is called in the singleton bean. So in the prototype scope bean, the pre-destroy method is not called, and therefore it is a developer's responsibility to do the manual cleanup. How they can do the manual cleanup? So it can be done like in the counter, there is written like cleanup, but it is not called. Why it is not called? Because the Spring by default does not track the prototype scope beans. Then how we can clean up? Then we need to do the cleanup by ourselves. How we can do this? So we can do this by like writing what we will do. We should write it in finally, but I am avoiding this, but we can do something like that. C1 dot cleanup, then we need to do C2 dot cleanup, and then C3 dot cleanup. So we need to do the manual cleanup. So now when we run it, now the cleanup is performed manually. So we need to do a manual cleanup, and this cleanup should be written in the finally block. So if any exception occur, this block will be executed. So we should write it in the finally block. So in the case of pre-destroy, in the case of singleton bean, pre-destroy methods are called, but in case of prototype scope, this pre-destroy is not called, because the Spring forgets about the prototype bean after returning it, and it does not track it. So the Spring does not manage the destruction of the prototype bean. So this was it for the today's video. I hope you clearly understand about what is the singleton bean, what is its life cycle, what is the life cycle methods, how to do the initialization, how we can do the cleanup in the singleton bean. Then we have learned about what is the prototype bean, how to use the prototype bean, what is the best scenario for using the prototype bean, when should we use the prototype bean, what is the difference between the singleton bean, and what is the difference between the prototype bean. So this was it for the today's video. In the next video we will learn about what is the proxies, what is the aspect oriented programming, and how the transactions are managed in the spring. So this was it for the today's video.